Number 6, 2019. Okay, so the function f and g and h are twice differentiable functions. With this information, g of 2 and h of 2 both equal 4. The line y equals, so this is tangent to both the graph of g and at x equals 2 and h at x equals 2. Okay, so I just write a couple things down. G of 2 equals 4. H of 2 equals 4. Just want to point that out. Pretty obvious. Oh, we have a word right here, tangent. This is a calculus term. So that's all we get from this scenario. Let's look at the first problem. The first problem says h prime of 2. Find it. H prime of 2. Well, we don't know what h is, so we can't take the derivative of it. But we do know this tangent line, and tangent lines tell us what a slope is and what the y value is at a point. So here, let me write this out. Y minus h of 2 equals h prime of 2 times x minus 2. This is pretty much right here what this is up here. Now we know that the h of 2 is 4 because we're told that. So if we look at this and then we look at this, we go, oh yeah, we would just have to add 4 to both sides to make it look like that. And then we know that h prime of 2 is 2 over 3 because it's in the tangent line that they give us. And so that's all you have to do. You have to write that. You don't even have to write all this stuff that I wrote right here. If you just wrote this, then you're good. All right, the next problem says, let a be the function given by this. Okay, so a has the h function inside of it. That's how he's related to these guys. Write an expression for a prime, and then plug in 2 to a prime. Okay, so for b, let's first take our derivative of a. So we're going to find a prime. Now when I look at a, I can see that it has two functions multiplying together. So that means we're going to use the product rule. So we take the derivative of the first one. That's going to be 9x to the second power times the second function. Then we're going to have the first function chilling while we take the derivative of the second one, which is what gives us h prime. After that, we're going to need to plug in a 2 to a prime. And so this is what we get. And then we're going to start simplifying that. 2 squared is 4, so we're going to have 36 times 4. So we go 2 squared, we get 4 times 9 is 36. H of 2 is 4 given to us up there. And so we write 4 again. 3 times 2 to the third power. 2 to the third power is h times 3 is 24. And then we have h prime of 2, 2 over 3. Hopefully I didn't get that wrong, otherwise I'm going to get this wrong. I know I like to write extra here. I just don't want to make a mistake. So let me write that out. 36 times 4, putting this some scratch work on the side right there. We get 144. And then we're going to go simplify 24 with the 3. And I'm left with 16. 16 plus 144 is going to be 160. But I don't like doing everything in my head on a test, and so I'm still going to write it out, double check it. Now let's attack this C. Now I'll be honest with you guys, when I first looked at C, I was like, what the heck? I have no idea where to go. And I sat here and I thought about it for a minute, and I thought, well, if I was a student taking this, I would skip it right now, and I'd move on to D. So I skipped it, went on to D, and I started writing some stuff out because there's a lot of stuff said right here. It says, it is known that G is less than or equal to H for all the numbers between 1 and 3. Okay. Let K be a function satisfying this statement. Okay, so it just said that K is in between G and H. All right, so that's what this is saying right here. For all numbers between 1 and 3. Is K continuous at x equals 3? Justify your answer. So I wrote this out, and I thought, well, if this is true, then this must also be true. Okay, and now we know something interesting because we know what G of 2 is, and we know what H of 2 is. We know that they equal 4. They equal to 4. So because I know that, I was like, okay, well then that means 4 is less than K of 2, and that's also less than or equal to 4. So this K of 2 must be 4. And I thought, wow, this looks very much like the squeeze theorem. So if we can say this, then we can also say this. And if we could say this, then we got our continuity here. Because I know that K of 2 has to be 4. It's the only number that would work right here. It's the only number that can be greater than or equal to 4 and less than or equal to 4. It has to actually be 4. And if I follow this logic right here, then this follows. It follows that these limits are the same. So, because of the squeeze theorem, because these guys also equal 4, I can say this, that the limit of k as x approaches 2 is 4, and that equals k of 2. That means k must be continuous. All right, go back. So this is actually the definition of continuity. It says if you want to prove that a function is continuous at a point, all you have to do is show that the limit as you approach x value equals a number that's the same as what you would get when you plug that x value into the function. Okay, so this is a definition of continuity, and I stumbled upon it. No joke, I did not see this coming. Just started playing with it because this right here looked like the squeeze theorem. I just kind of took the clues and went with it. All right, so now we got to attack C. So without further ado, this is what I thought. I'm like, okay, so we know that this satisfies the h function, but it doesn't satisfy it at x equals 2, which is kind of weird because we know what h is at 2 because it told us. All right, but this doesn't work at x equals 2. Weird. This is really weird. It's known that the limit of h as x equals 2 can be evaluated using L'Hopital's rule. Okay, that's great. So like if we took the limit of this, we can use L'Hopital's rule to find it. Okay. Use the limit of h as x approaches 2 to find f of 2 and f prime of 2. Show the work that leads to your answer. So this is what I first thought. Well, I'm going to write out the limit as x approaches 2 of this function h. And then I thought, okay, well, what would it look like if I did L'Hopital's rule? So now I have 2x on top, and on the bottom I have some funky things happening. I have f and f prime. So now I have my f and my f prime. And then I started thinking, well, I know that h of 2 is 4. H of 2 is 4, so that must mean this has to equal 4. Because h is a twice differentiable function. We're not going to have like some kind of removable discontinuity or something like that, because if we do, then it wouldn't be twice differentiable, right? So we know that h is continuous, and so that means this has to equal 4. It has to. And so I wrote this and I thought, well, if this and this equals 4, then, I mean, both this limit and this limit equals 4, then if I plug in 2 to this, I should get 4. But then when I did that, I saw what happened right here. This guy gives me 0. Look, 2 squared minus 4 is 0. So then I thought, well, then here you go. This is the ticket. If this is 0, and it says that we can use L'Hopital's rule, check this out. It says that we can use it. The only way you can use L'Hopital's rule is if you get an indeterminate form. That's 0 over 0 or infinity over infinity. And there's other indeterminate forms, but those two are the more popular ones that you'll probably see. So if we got 0 on top, and I know I'm supposed to get 4, so we would have to do the L'Hopital's rule right here. So that means this right here, the denominator, that guy must equal 0. So if he must equal 0, now I can solve the f of 2. So if I 0 over 0 to get L'Hopital's rule. Alright, so I just got to subtract 1 from both sides, but then both sides are negative, so I get rid of the negatives, and this is what I got. Now I do the third root of both sides, but I didn't actually write it, I just crossed out the 3. Then I got f of 2 equals 1. Now that's crazy cool, because now I can plug that into this after I plug 2's in, and I'll be able to find f prime of 2. So this is what I got. I got 2 times 2 on top. I have negative 3 times f of 2 raised to the second power times f prime of 2 right here. Then cleaning this up, this right here, f of 2 is 1. So I plug that in. There you go. 1 to the second power is just 1. So we have negative 3 times f prime of 2. And that's all under 4. And we know this equals 4. All right. I cross out the 1 to the second power because he didn't do anything. Alright, so now, let's clean this up a little bit. I can multiply both sides by f prime of 2, so he's not on the bottom of a fraction anymore. And then I can multiply both sides by negative 1/4 to get rid of this 4 hanging out with the f prime. So now I have 1/4 times the 4 over negative 3. And I see that the 4's cancel out. That's really cool. And so f prime of 2 equals negative 1/3. Wow, what a journey that was. And I honestly didn't see the pathway for C or D right away. In fact, I had to double check my answer. I'm not even sure if I got D right. Let me go check it really quick. Yeah, it looks like I got it right. I mean, I didn't write a lot of words the way they did on their scoring guide, but I am using the definition of continuity. I did use the squeeze theorem. The only thing I didn't do, I didn't say thus because of the squeeze theorem, and that's what the College Board said on their answer key. But if they really wanted you to say something about the squeeze theorem, they would say that in the points. They would say they get a point for mentioning the squeeze theorem. So I don't think you had to say that. You just had to follow the logic on it.